Today we're going to learn about absolute value equations, and what we have learned before about absolute value is what it represents. Absolute value is a representation of distance. And specifically, it's distance from zero. Now, since it represents a distance, absolute value cannot be negative. So it's going to have to be greater than or equal to zero because you can travel a zero distance. So let's take a very basic example of the absolute value of x. What we want to look at is what values of x will give us 2. So if we look on a number line, and we find numbers that are a distance of 2 from 0, we get 2 and negative 2. So that means x could be equal to 2 or negative 2. So let's say that we want to look at an example. It's a little bit more complicated. So I'm going to put a coefficient in our absolute value, and I'm going to say 2x. The absolute value of 2x is equal to 4. So what we're looking at is inside the absolute value, you can either have negative 4 or positive 4. That's what 2x is going to equal to. So 2x can either be negative 4 or positive 4. So let's write that out. So we have 2x equals negative 4, and that means x equals negative 2. And then we're going to have 2x equals positive 4, and x could equal to 2. You're going to have 2 solutions to most of your problems. Now, most of your problems, well, not most, some of your problems will have additional things multiplied to the outside of your absolute value or added to your absolute value. So before you solve, you must solve for the absolute value. You're going to treat it like its own variable. So you're going to solve for the absolute value. And we're going to have an example of that in just a second. So let's try one. Let's do example 1. And I'm going to zoom in a little bit on this one to make it easier for me to write on this tablet. Okay, so if you looked at our examples above, we took what was inside and we set it equal to the positive and negative of what is outside. Don't ever change what's inside the absolute value. So 2x plus 3 could be negative 5, or it could be positive 5. So that's how we're going to set this up. So 2x plus 3 equals negative 5. And then we're also going to have 2x plus 3 equals positive 5. And we're going to solve these two equations separately to give us the two values. So on the left, let's subtract 3. And then we're going to divide by 2. Now on these videos, I tend to move on pretty quickly. So if you need to at any point in the video, pause it and catch up on your notes, or practice a problem, or work ahead and see if you understand. Okay, so the two values that we get are negative 4 and positive 1. It's a good idea always to check, at least in your calculator. If you're good with arithmetic mentally, you can do it mentally, but I'm going to demonstrate for you how to check the negative one. Put it into the original. If you don't put it back into the original problem, it's not going to check correctly. So, I put it into the original problem, and this is really a question, are these equal? And I'm going to have negative 8 plus 3, is that equal to positive 5, excuse me. And so we have the absolute value of -5 is equal to 5, so this checked. So checking is very simple, and it's nice because it confirms whether you got your problem right or not. Okay, so let's come over here to example 2, and same arrangement here. We are going to take what's on the inside, y minus 0.3. We're going to set it equal to the negative of the outside, and we are also going to set it equal to the positive of the outside, like so. So why don't you give this a try and pause the video and come back in just a second and see if you got your answer correct. Welcome back. If you got 0.2 and 0.4, you got the correct answer, and I checked the negative one. What some students do, here's a mistake that a lot of students make, and I'm going to write this but you're not, is that they will decide to solve the positive one and they would get a 0.4. And they know there has to be a positive and a negative somewhere, and so they would go, oh, my answers are 0.4 and negative 0.4. Well, if you plug that in and check, you're going to see that that is not correct. And since that is wrong, I'm going to erase that. All right, let's move on to the next example. All right, this example shows what I described before about needing to solve for the absolute value, because this absolute value has a +2 attached to it. So we want to solve for the absolute value first, and we're going to begin with adding the 2 to both sides. But we're not going to take down the absolute value yet. So we have the absolute value of 2 plus 6x equals 4. Now that the absolute value is alone, now you can separate it. Don't change the inside, only change the outside. Alright, and this looks like an equation that you can probably solve pretty easily. We're going to subtract 2 on this one, and then we're going to divide by 6. And our first solution is -1. We'll clean that up just a little bit. Alright, the other side, we are going to subtract our 2. And that's going to be equal to 2. And then we're going to divide by 6. Now, whenever you get a fraction answer, always, 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 always reduce. Now, if you're not one of my students and you're cruising around YouTube looking for math help, I don't know how your math teacher feels, but this math teacher does not like you to take this fraction, which is perfectly fine just the way it is, and turning it into a repeating decimal. This math teacher doesn't look upon that favorably at all. So do what your math teacher wants, but if you're my student, leave it alone. It's happy just the way it is. Okay, so by now you should be getting the idea of the problem. So I want you to do this one and come back in a second after you have done it and check your answer with my answer. Okay, I got x is equal to 3 and x is equal to -1/3. Let's practice checking the -1/3. So we're going to check this, plug in the -1/3. We're asking the question. Okay, 3 times -1/3, those are reciprocals, so that makes 1, but it's negative. And -1 minus 4 equals 5, question mark. -5, absolute value, equals 5, and that does check. Okay, so this problem looks a lot like what we've been doing except for one thing. What do you notice? This is equal to 0. So if we have been setting our absolute value equal to a positive and a -0, we don't have a -0. So we're going to just write 7k plus 14 equals 0. So what does it mean? All of our other examples we have had 2 answers. If you're going to be equal to 0, you're only going to have 1 answer. So we are going to solve for our variable and k is equal to -2, and it's only equal to -2. There will be no other value that would make our absolute value equal to 0. So look for these. Only one solution here. And we're only going to do one more example. Here's our last example. Alright, in the very beginning, we defined absolute value as a distance. So let's review that a second. Absolute value equals distance. Distance can only have what values? It can be 0 or it can be positive, which means it has to be greater than or equal to 0. -4 is not greater than or equal to 0. Is it possible to have a -4 absolute value equal a -4? No, that is not possible. So, in a situation like this where you have a negative answer, you will have no solution. So let's wrap this up a little bit. We learned how to solve these equations, but we also learned another thing. If your absolute value, we'll just say x, is greater than 0, you're going to have two answers or two solutions. Second thing we learned was if the absolute value is equal to 0, you will have one answer or one solution. And the third thing that you learned is if your absolute value is less than 0, if it is negative, there will be no solutions to this. So keep that in mind as you practice problems, and I hope you enjoyed this lesson. If you are my student and you have an example 7 on your note sheet, we are saving that for another day.